Hey everyone, my name is Adam Corbin, and I'm going to present some software engineering mini lectures. Dr. Huang asked me after I talked to her a little bit about my experience. The first mini lecture I'm going to go over is really just my background and just kind of give everyone context of what I have done. And so this is just a little PowerPoint slide that I usually present to people when we do like get to knows within the company. So I'll start. I was born and raised in Florida, actually over in Clearwater, on the other side of the coast of where FIU is, near Tampa, and so I grew up as a competitive swimmer. Started around when I was like 6 or 7. Competitively swam through high school and swam in college at FAU. Graduated at FAU. I studied computer engineering, graduated 2011 with my master's in computer engineering, and right away started working at GE Aviation, which is in Clearwater also. And so yeah, I've progressed there. I've been working there for 7 years, and I'll just jump in a little bit here. Here I first started working. I've only been working like 3 different projects in the 7 years I've been working here, so it's kind of interesting. But in aviation, projects tend to last a really long time, and then there's just so much processes and documentation and getting everything squared away before it even gets into the plane to be flown. So, but the first project I worked on was HMS program. That was the aircraft health management system. So basically what that did was it collected a bunch of sensor data on the planes and monitored them based off certain predefined ranges, and when the sensor data went out of range, it would collect data even more often. And some of the stuff I worked on there was report generation, so taking that information, putting it into a JSON format, and actually sending it down to the ground. So that was something that was recorded in there and can send it down to the ground for like more diagnostics. And so the concept here was we made it so that there could be some live debugging of sensors or any electronics on some electronics on the plane, mechanical electronics and different things like that. And if there was something that was out of range, they could potentially order parts to a specific airport and try to fix that plane quickly before diagnosing things on the ground. So as long as the plane is continuously staying up in the air, the companies are saving money. And so this was actually for excuse me, for Gulfstream jets. So these are like small business jets: Gulfstream, Bombardier, and also C919 Comax from China's commercial airplane that's going to be in entry service in the next couple years, I think. So I also worked on programming the LEDs on the box. It was kind of interesting. So GE Aviation is pretty big. They have lots of different sites, and the sister site we work in avionics, basically just all the small electronics in the plane. And there's another site in Grand Rapids, Michigan that we work with quite extensively. So that's kind of where this project was based out of. And so I was tasked to help program the LEDs on the box, the only visual representation. And so it's interesting working in Clearwater trying to visually debug something which I actually never saw. So it's kind of interesting that you can kind of still work globally on projects. So that was interesting. Then the next thing got moved on to is TrueCourse, which is a flight management system that I like to explain is like the Google Maps of the plane. Basically, this is where it's in like the center console of the plane where the pilot will enter in they call them company routes, and then make some modifications. Basically, it's like the different waypoints from your departure to destination airports, manipulating the waypoints, setting different maybe altitude constraints or speed constraints, maybe doing lateral offsets if there is some kind of like weather issue, rerouting, making different flight plans. And so I was asked to help lead a group of people in the flight planning area. So basically, flight planning is just they're the database that controls and monitors the different waypoints and how the pilot operates. So also part of the flight management system, there's some groups in the performance predictions area that they will compute through the three-dimensional path for the plane for fuel efficiencies and stuff like that. So that group was around 5 people. Was leading that for about a year and a half, and then moving on. The project just expanded. So today the project almost has 200 engineers on it. Probably around 50% are software engineers and 50% are like requirements and verification engineers, including systems. And so this group, just there was so much demand, we kind of expanded it to around 16 people. So I was kind of like leading all 3 of those teams. It was split up into 3 teams. I was kind of like leading all the 3 teams, kind of figuring out where we wanted to go from an architecture standpoint and efficiency standpoint. And I also forgot to mention that GE has been working on these FMSs for many years, and they've had a lot of different customers, and the TrueCourse project is supposed to be more of like a product line system, which means we will work on core set of code or a core set of requirements and code and verification to be able to reuse on multiple customers. Currently we only have one customer, and that's Comac, the C919 plane, but trying to get multiple customers. And so setting up in a way that we have a core set of functionality that can be used across other planes, and then being able to diverge between different customers. So something that Dr. Huang did talk about a little bit, and I know that she's going to be talking about it in the future in another lecture, and I will too, specific in one of my mini lectures. So it's something that's pretty interesting on trying to handle. So it solves a problem that we ran into in the past, and that is we had many customers in the past. Toshiba, P8 with the government, the P8 plane refueler, KC-46, C-130 planes, and what ended up happening was there's just like a copy and pasting of basically core set of code and requirements and stuff like that. So they copy it, paste it, and that ends up being problematic when you have multiple releases, multiple customers, and when you start running into having bugs or problem reports and making sure that that bug gets fixed in all other customers' releases became challenging. Like some in the projects were run separately, so people were not always aware of what was happening in the other projects. So there was many cases where a big bug was fixed in one project and never got migrated into another project, and customers were finding and reporting those issues. So it's something that the product line system is supposed to help combat, to making the product more quality. And then about a year and a half ago, I ended up transitioning to more of a people leader role, technical manager role, with spending most of my time developing talent within the groups, making sure that the software is quality. So this is for basically a software manager, but I still spend probably the other 50% of my time still working on the TrueCourse project, trying to make it more efficient and operate a little bit better. Some of the interesting things working on is we used a configuration management system from IBM called Rational Team Concert. We used that for probably 5 or 6 years, and I was leading the transition, and did investigation and leading the transition to move over to a Git repository. It seemed to be a little bit better, scalable, and a lot more industry standards are using Git, which is something that's pretty interesting to me, to make it so that it's something that's maintainable, and especially if you ever need to Google a problem, it's very easy to find solutions to problems at Git versus if you Google anything from IBM's RTC, that it can be challenging finding answers. So that's another mini lecture I'll jump into, talk about software tools and how it can be used, and also configuration management. I won't go too deep into that. Also on the side, I've been doing adjunct professor at a local community college at SPC, St. P College. Basically teaching some online courses. Probably have taught the past 6 years. I've taught probably maybe about 40 classes. Most of them are like intro to programming, like Python, Java, Java 1 and 2, JavaScript, SQL, iOS apps, some C# classes, and Android classes. I also have some pictures down here of things on the side that I like. I like spicy foods, hot peppers, grow some hot peppers, Carolina Reapers. If you Google that, that's like the hottest pepper in the world. It's kind of crazy. Worked on a little bit of iOS apps and Android apps and Raspberry Pis. So that's something that if you guys ever have any questions about Raspberry Pis, I've done a lot of stuff with that. So created a Raspberry Pi, connected up to my garage door with an ultrasonic sound sensor to know whether or not it's open or closed, and also had a relay switch to be able to open and close it remotely too with a web server. So also have a Raspberry Pi with a bunch of websites hosted on there for free. That's kind of interesting. For Android, last year I tried to do some kind of like projects every year. Last year I spent the whole year developing a Android app in Kotlin. I don't know if anyone is familiar with Kotlin, but it's an interesting language that Google has adopted as kind of like the next Android language. But it's a really beautiful language that works seamlessly with Android Studio. But yeah, so I worked on an app there doing technical analysis on cryptocurrency. So use a few actually open source libraries on GitHub, kind of combined them and made some of my own flavors to kind of work together using CryptoWatch for the data, getting the data for all like the different cryptocurrencies and being able to do the charting of and technical analysis of those cryptocurrencies. So it's pretty interesting. You want to take a look, it's on the Play Store called CryptoWatch, or no, sorry, not CryptoWatch, CryptoTA. So that's, take a look at that. And then this year, one of my side projects I did was I created a Nixie tube clock and connected it up to a Raspberry Pi as like the master node controller to be able to control the different Nixie tubes. So Nixie tubes is like an old, before LCDs from the 70s. I think that's how they did like a it's kind of like an incandescent bulb, but very steampunk like. They were made in Russia. They don't make them anymore, and so it's actually really interesting. So you can Google Nixie tube clocks, and I actually contributed to an open source project too. You can look on my GitHub; it's pretty interesting. So, so yeah, I think that. Oh yeah, final last thing was Alexa. Wrote a few Alexa skills. Every once in a while, they have promotions. Like my first Alexa skill, they said if you did an Alexa skill, you can get a free Echo Dot. So I did that, and then maybe like a couple of years later, they had if you did an Alexa skill, you can get an Echo Show, which is basically like the tablet form that can go on like a table. That was pretty interesting. Yeah, so that's a lot of different experiences doing different things, whether it's work related or side projects or in education. So I'm going to take some of my experiences and talk a little bit about software engineering in these mini lectures. So hopefully you find it helpful. We'll end it here on this intro, and then I'll try to do, this will probably be the longer one just to get a background of me. I'm hoping to be between 5 and 10 minutes mini lectures, and so yeah, we'll end this one and we'll move on to the next one. Thanks.